All right, we are live. Hello, everyone. Good morning if you're on my side of the planet. Good afternoon, good evening if you're on one of the other sides. Was talking in the chat with some people before we got started. Seems like people are coming from all around the world, which is really cool. What I am doing today is I am working through this cool little notebook that Jeremy Howard of Fast AI shared recently. It is a Kaggle notebook, so it's associated with the Kaggle competition. And so that's, if you're in the Kaggle community, this is kind of a fun competition that you might want to be interested in. I personally don't use Kaggle that much. I found this interesting because I really like the way that it approaches this problem of understanding this competition and how to use LLMs for this competition. I think it's like a general approach to thinking about how to use language models for lots of different kinds of ML problems, places you might apply language modeling. So there's a focus on exploratory data analysis, which we'll spend some time on, and sort of like understanding this data and what the task is that you're trying to resolve. And we'll focus on that for a while, and then once we get towards the end, we can try out a couple of different things. I had some ideas about either more ways that we could do exploratory data analysis. We could try out just switching the model for GPT-4 to see if we get improved performance, or we could try the OpenAI function API. So time permitting, we'll try out some of those ideas. And let me take 1 second. I noticed somebody mentioning an audio issue. I think I might be able to help them out with a quick switch. That should resolve any spatial audio issues. So this is only the second or third time that I've been streaming, so please bear with me on any of those kinds of issues. All right, so let's talk. Let's get a little bit more context on this one by checking out the actual Kaggle competition. So the here's this Kaggle competition page. It introduces the kind of like goals of the competition. It's actually supported by Google, I noticed while I was reading through the documentation. This is actually, it's about understanding how well LLMs can like test their own knowledge. It's also got there's also an angle to it around LLMs in resource-constrained environments. So in Kaggle, you have limits on the amount of resources you're allowed to consume. You kind of hand off your code for them to execute, and you aren't allowed to call web APIs. At least in this competition, you aren't. And so that limits the amount of resources that somebody's allowed to consume in trying to solve this problem. So the structure of the Kaggle competition kind of like ensures that people aren't just throwing really, the largest models and tons of compute at the problem to try and solve it. And so there's a ton of interest, even from the people at these big labs who have tons of resources, on what happens with, sort of smaller resource budgets. So they have created this data set by giving GPT 3.5 snippets of text on a range of scientific topics pulled from Wikipedia. So we've got like chunks of Wikipedia pages about science, and then GPT 3.5 writes a multiple choice question with a known answer. So there's like the answer is in the question, is in that passage of text, and it just generates a multiple choice question. If you've ever written any multiple choice questions yourself, like I did back when I was teaching at Berkeley, that like generating a multiple choice question when you know the answer is kind of formulaic. You just kind of edit the little pieces of it. You change things, change one word around, use not to flip the meaning of something. So getting a similar thing out of GPT 3.5, and then they mentioned filtering out easy questions. So this is our data set. This is the data generating process here looks like something up on Wikipedia, use a language model to write a multiple choice question, and sort of pick back out what the model was told was the correct answer. So I think it's really helpful when you're looking at these like data sets to think in terms of data generating processes. Like, how did this data come about? Often it comes about from like observing the natural world, running a sensor on something, or running a survey on people. And that data generating process is what your model is going to like be trying to mimic, right? And so in this case, our data generating process is we're sort of trying to mimic GPT 3.5's behavior to a certain extent. We're trying to like retrieve a secret that it's trying to hide from us. That's another way of thinking about what we're trying to model and understand. And an important fact that will come back again and again is that this is distinct from actually getting the questions correct. That the correct answer to the question may not be the information that was on Wikipedia. Wikipedia does, in fact, have things that are wrong on it. So that definitely changes your strategy if you're trying to, maximize your performance on this, which is distinct from trying to make, the smartest possible language model. So that's, one way where these kinds of like benchmarks and competitions are maybe a little different from real life, where you would just try and you would assume that your users care about maybe the smartest possible language model. All right, so that's our kind of like overview of this competition. Let's dive in and start playing around with it. So yeah, again, this notebook here is written by Jeremy Howard of Fast AI. I think I have a link I can share with you if you want to grab. There we go. Yeah, so that's shared a link in the chat that is the link to Jeremy's version. I'll be working on my own version here. If you want to, sort of fork and play with it yourself. It was pretty easy to get going. All right, so we'll ignore. I've been running some cells and playing around here, so we'll ignore that first cell, which just sets up the environment and install some stuff, and let's talk about let's dive into actually looking at this data. So first, we've got some notes about this science exam competition that we've already talked about. We bring in our imports, and there are a couple of files in the competition. The most important one is our training data. I checked out also the test data. It looks like the test data is the same as the train data, so we don't really actually have a test set. So if we wanted to do holdout validation, we'd be responsible for doing that ourselves. But yeah, let's take a look at that training CSV file. Probably the best way to look at a CSV file is to turn it into a pandas or polars data frame and load it up and take a look at it. So what we've got in here is we've got a column called prompt that's got our question. That's our multiple choice exam style question. Which of the following statements accurately? Which of the following is an accurate definition of? They kind of have this formulaic kind of structure to them. And then there's 5 possible answers, A, B, C, D, E, each of them, and are the correct answers indicated with this column all the way on the right, this answer column. So we're trying to output the correct answer. This is at this point, now that I've seen the data a little bit, now I'm actually starting to get a little bit more curious about what exactly evaluation means, because I was about to say that our goal is we want to put out the exact correct answer, but you don't actually know that just from looking at the data. That's we know what the correct answer is, but we don't necessarily know how things are scored. So let's swing back to this description and head to the evaluation tab here. All right, so turns out the math rendering on Kaggle is a little wonky with my dark mode, my hacky dark mode. But the TLDR of this part here is that your goal is to just get one of your top 3 answers to be the right answer. So mean average precision at 3, it's like a common, common metric used in things like ranking or retrieval. So if you've been doing retrieval augmented generation with LLMs recently for like question answering, your goal might be to have the documents that you return to have the right one, have the right entry, the desired document somewhere in the stuff that you retrieve. So that's where I've seen this like mean average precision at 3 or precision at 3, recall at 3, these kinds of metrics. So it's got a complicated formula, but the basic answer is that you are asking, is one of your top 3 answers the correct one? So that's going to be the final evaluation metric. Of course, when we do things like train our model, we're allowed to pick anything as the way that we like train and update our model. So we don't necessarily have to use this as the thing that we use to like calculate gradients, for example, if we're like fine tuning a language model. I see a question in the chat from Walisa 100 million now. Side topic, I think I've read that having code and pre-trained corpus for LLMs helps with non-code tasks. Do you happen to have links to such claims or a study? Yeah, there's a great, actually, Notion document by Yao Fu that's called How Does GPT-3 Come by Its Ability? I think that's roughly the title. I don't have a link to it offhand, but if somebody wants to look it up and share that in the chat, I'd be appreciative. I'll say it definitely is in this LLM Lit Review little database that I've been putting together of some of my favorite papers. So if you look in there for evaluation and code, you might be able to find it under those tabs. But yeah, I think in general, that's a widely held belief. Yeah, the language models get smarter with code. To tie it back into this competition and this question we're thinking about right now, the other thing people have found is that textbooks are all you need. I think that might even be literally the title of the paper. There's a recent result, I think, from Microsoft research that you can get like a pretty smart language model if you train it on a like curriculum of synthetic and real textbooks of information. So sort of like rather than training it on like a giant corpus of internet data. So that's kind of a cool result. It sort of looks a little bit more like the way humans learn, which is appealing to some people. Maybe people who came from neuroscience like me like that, like it when language models and machines are more similar to humans. Yeah, it would definitely make the language models better at answering science trivia questions if they've been trained on science textbooks. So when you're using, I think most people are probably going to approach this Q&A, this LLM Q&A problem by using like a pre-trained model, by using something out there that already knows something about this problem rather than starting from scratch. In a lot of Kaggle competitions, you might start from scratch. So if you're doing that, then you definitely want to understand like what was the language model trained on, so that you know whether it's so that you can choose between all the potential options. Like some of the open weights available in open source models have more data from books and textbooks and scientific papers. Some of them have less. They have more information from chats. They have more information from more conversational human text, and that might affect their performance on this. So Dan asked kind of a related question. When you talk about training an LLM, do you mean fine-tuning or training from scratch? I don't know exactly what context you're asking that in. I don't remember when I might have said training an LLM, but I'd say just in general, training a large language model, which means to me training like a 7 billion parameter or larger language model, that is going to require a ton of resources, like definitely bare minimum at least 8 by 8 accelerator, so 8 A100s or H100s, 8 TPU, or a big TPU pod. Like, you're going to need a lot of resources for doing that from scratch. Fine-tuning you can often do with much closer to consumer hardware, So like with techniques like LoRa and soft prompting / prefix tuning, those kinds of adapters, and especially QLoRa, which does all of this at low precision. Those are great techniques for fine tuning that you can do at a more reasonable scale, that it massively reduces the amount of VRAM you need to train. So definitely the fine tune. Okay. I see from Dan mentioned the training in LLM on textbooks. That particular example was from scratch trained on textbooks. All right, let's jump back in here to the actual notebook. Can I close that tab? Great, love that. Get rid of that guy. And let's jump back into looking at this data. So now we understand a little bit more about how we're being evaluated. One of the things that I really like to do, and this is something I've seen recommended by lots of people, including Andre Karpathy, is I like to take a look at the inputs and try and learn to do the task myself, and practice the task myself before I hand it off to a language model. Or actually not just the language model. Language models are easy because the inputs and outputs are text, and so it's like pretty easy to display the inputs, to input your preferred outputs. It's like, and it's natural language, so it's generally understandable for humans. But with any kind of ML model, it's a good idea to learn a little bit about how this task looks from the inside. Develop some empathy with your models. So let's try this out for a little bit. All right, so our first question comes in. What did Newton adopt after his correspondence with Hooke in 1679 to 1680? This is our first science question. So I would say this is not a very not a particularly science question. This is maybe a little bit more of a history of science question. So the question, so this is going to definitely be a challenging one. I'm mostly guessing here, but I would say that it's probably inward or centripetal force, or outward or centrifugal force, I would have to guess. So let's try, let's just try one of them. Okay, so the correct answer was A. So in my top 3 answers, I guess I did have the right one. So I might adjust my testing code here. So I've got a little bit of testing code that shows me the example and asks me for an input. So I might swap that around and say example answer in my answer. So change the way that I'm grading it to be a little bit closer to the way that the model might actually be graded. So what are permutation inversion groups? Wow. All right. So permutation inversion groups of symmetry operations that are energetically feasible with respect to the center of mass. Okay, inversions or rotation. Combination of both. Entire molecule about the C3 axis. All right, so one thing I'm learning from this is there's a lot of very specific information that's required to answer these questions. These aren't like general knowledge science questions. What I would think of as like a general knowledge science question might be like, how many atoms are in carbon, or not atoms are in carbon. How many protons are in carbon. Or questions, very like common knowledge kinds of science questions, like are birds evolutionarily descended from dinosaurs or something? But these are challenging, I would say, science questions as somebody who's done quite a bit of science in my life. So I'm gonna guess that it's BA or maybe E, and see what I got. All right, so the correct answer was E, which is my third answer. So that's technically a correct answer from the from the perspective of the evaluation, even though I didn't really have a great reason for picking that one, those 3 answers just seemed to be the ones that mentioned permutation and inversion, both of them. So that's suggesting to me that one really good technique a model might learn when faced, like, fine-tuned on this data would be to, like, pick out the, like, patterns of language in the top couple of answers. Like, pick out patterns of language that are shared between, like, 3 answers and the question, and then just answer with all of those. That would be, like, a pretty easy way to kind of hack this metric. So that's another thing that you can learn from trying these tasks, even if they're really, really hard and you don't have the context for answering the questions yourself. Like, trying it will encourage you to, like, come up with ways to cheat, and models tend to cheat and come up with cheap ways to answer questions. So continuing our one last one here. What is the Kelvin-Helmholtz instability and how does it affect Earth's magnetosphere? Yeah. Man, not enough neuroscience questions and not enough machine learning questions in this science QA. If you want my opinion, that's much more my style than this earth science stuff. All right, Kelvin-Helmholtz instability is, this one. No, I don't see any obvious patterns like I did in the last one that might make me answer it, so I might kind of guess a little bit more randomly here. The first one is longest, so I think I'm going to guess it's actually that first one. Then the last one is also pretty long, and so I'll guess that. And the third one... another technique that also works, if you remember from that I'm remembering from my time answering exam questions, is figuring out which answers it's not. So it looks like answer C doesn't look particularly likely to me. Kelvin-Helmholtz instability is a phenomenon that occurs when Earth's bow shock is about 17 kilometers thick. That doesn't seem like a particularly good answer. And D doesn't seem like a good answer to me either. All right, so just picking the longest answer was enough to get this first one right. So that's another kind of statistical pattern that a language model might pick up on, allowing it to do really well on this question, allowing it to do really well on similar questions without the model having to learn anything about the actual statistics of, without having to learn any actual science, without having to get any actual understanding or a world model. So I've spent a long time on just this part of, like, examining the data. I think that is a really good idea. I would spend even more time on this and be, like, writing notes on the side to myself if I were doing this for real. I'll probably stop so we can get to some of the coding and some stuff that's a little bit more transferable to other problems you might try and tackle. But I feel like that process is just, like, invaluable for learning more about your data and uncovering, like, issues where you can fool yourself into thinking that your model is going to generalize better or do better or learn more than it's actually going to learn. And this is something that kind of bit a lot of the like vicuña, alpaca, guanaco. A lot of those models thought that they were getting, much closer to ChatGPT's level of, performance and quality. But part of that had to do with the model just learning these kinds of basic features of text that cause humans to prefer certain responses over others, like length of response and formatting and things like that. So I think even really sophisticated teams will often kind of forget this step and spend too little time on it. All right, let's keep going and get to a little bit more live coding. All right, so we've done a little bit of exploratory data analysis there by hand. And exploratory data analysis by hand is great, but normally we would do that EDA, as Jeremy points out, by doing things like taking histograms. And actually, I still think that that would be a good idea. Like, you might find that the longest answer is more likely to be correct. So we could test, we could kind of like test our hypothesis a little bit. We could maybe try and come up with some more rule-based system for guessing the answers, and then check how well we can do on that. But I think that is, so I think that's definitely an important angle of attack. But I kind of like the point being made here by Jeremy, which is like, this is a natural language competition, so it's like probably more like sensible or useful at the start to do your exploration in natural language, like I was doing with looking at the results above. All right, so I'll also update my to-do list. We've explained the context, we've gotten the data, we've done a bit of our data deep dive. We're kind of on that right now, actually. So I'll say we're on the data deep dive right now. And a question from Raceman100 in the chat: is this cheat first phenomenon common when training? I would say yes. In my experience, models learn heuristics that like kind of help them cheat on a data set, like loose patterns that work for the majority of examples but aren't the like true underlying pattern. And they learn that first, and only with a long period of training on more data or for more epochs do you get models that actually learn stuff. So I think there's a bunch of different ways that you can observe that. All right. Yeah. So let's. So the way that we're gonna start exploring the results now is by checking what ChatGPT's answers are, or well, more specifically, the GPT 3.5 Turbo, what that model's answers are on the questions. This is the same model that wrote the questions, so that you might expect it to do decently on it. Of course, the model wrote the questions while it had access to the answers, so it's not necessarily going to get perfect performance. But yeah, so we look at an example. Just because we're passing it to the model doesn't mean we shouldn't look at it. This is a question about the theory of modified Newton dynamics on the observed missing baryonic mass discrepancy in galaxy clusters. This is an astronomy question. Not much of a cosmologist, but this is kind of like a dark matter thing. It's like galaxies are not as big as they should be, not as massive as our guess for their mass doesn't match their gravitational impact. And so I would guess this is a theory that, from its name, modifies Newtonian dynamics to resolve that issue. And so looking at these, postulating the existence of a new form of matter, increases the discrepancy. That's not likely for a theory. Theories are supposed to resolve discrepancies. So theories explains that was considered dark matter by demonstrating the massless form of neutrinos and axions. Possible, but why would it be called modified Newtonian dynamics? D, this really looks like the answer here, reduces the discrepancy. This one, not sure that this is the answer. It just says that it reduces the discrepancy. E is an answer that says imposing a new mathematical formulation of gravity does not require the existence of dark matter. I would guess D or E on this one. Looks like the answer is D. So let's see how the model does. And I'll get to, there's a question in the chat from Saif Mohammed. I'll get to that in a second once we've tried out the language model here. So if you were running this yourself, this is the point where you would add your OpenAI API key. You actually could swap this out. We're using this nice LLM library from Simon Willison, who also made Django. This LLM library, you can do different types of models in this library, not just the OpenAI one. So if you have an Anthropic API key, you should be able to swap that out too. But this is the point where we're using an external language modeling service. Yes, if you have Llama 2 running, you could try Chat Llama 2 or even regular Llama 2 on that and see whether it works. All right, let's run the model on the first on this question here. So the way that this library works is you pass prompts. You like generate a model by picking it out from the list, and then you pass the prompts in with this .prompt function, and we get back a response. I'm actually kind of curious what this response object looks like. All right, so it looks like this response looking kind of like it might be some kind of Pydantic thing. So let's see. LLM.models.response. Yeah, so I bet this is like a Pydantic thing. It's like a JSON-y type object. Yeah, so it has a .json method, so we can see things, not just the answer here, but also things like metadata about the model and the role in the conversation, which is part of the OpenAI chat messages format. And we also get the content here. And that's the model's answer. It looks like it got it right. And it looks like it also got it right the time that Jeremy ran it. Okay. And so question from Saif Mohammed. Does the type of data affect the performance of the model, especially here in the context of the competition? What is good data for fine-tuning? How do we know these type of questions are a good fit to fine-tune the model? That's a great question. So I think it depends a little bit on what the evaluation looks like. So the evaluation we can take a look actually at the evaluation section here. I think they might mention, oh, it's not in the evaluation section. I think it's in the description. They talk about how you'll be evaluated. So the goal is to answer difficult science-based questions written by a large language model. So it shouldn't, it's not like we're going to get human written questions that are super different. But we might see, they mention the data section. This is where they talk about it. So, they've included 200 sample questions with answers to the format and to give a general sense of the kinds of questions in the test set. However, there may be distributional shift between the sample questions and the test set. So solutions that generalize to a broad set of questions are likely to perform better. So they're saying that these are going to be multiple choice questions written by an LLM, but they might be like quite different in topics. So like a lot of the ones that we've seen so far seem to be we saw lots of physics-y questions. Maybe the test questions are going to be like biology themed, or maybe they're going to be like more chemistry and less like earth science and cosmology. So that's a possible distribution shift. I think in real life, when you're not in a Kaggle competition, you maybe have a better sense for what your end downstream goal is, like what actual service are you trying to provide to users, and what do users of your library or your application actually care about. So in this case, we don't really know, which is an unfortunate feature of Kaggle competitions, but so you would let that drive your choices about fine-tuning in real life. For this, I would say that fine-tuning a little bit on these questions is probably important, but I would be very, very cautious about overfitting onto these questions, because this is a very small number of questions. So I think they are probably expecting you to generate your own data. So given that this data generation process is pretty easy to replicate, you can get information from Wikipedia, you can pass it to GPT 3.5, and get answers. Like, they're probably expecting you to generate your own data and fine-tune on that. So I would probably do a mixture of carefully selected questions myself, maybe grab some from, if I have any old textbooks lying around, grab some multiple choice questions from that. Maybe think standardized tests have questions in them. And do some of that fine-tuning. I think an important feature of the fine-tuning is also going to be just about output formatting. There was some interesting recent work from DeepMind that small language models are actually able to answer questions, but have trouble a little bit with like mapping that answer onto a multiple choice response, unless they've been fine-tuned to do that. So like a little bit of fine-tuning feels like pretty necessary, like fine-tuning to train the model that its primary goal is to like output these options to like come up with the answer in its internal computations and then map that answer onto one of those letters. Right. Okay. So hopefully that answers that question about fine tuning. And let's keep going. So one of the most useful ways to explore data is to look through where does some kind of model that's not perfect get things wrong. So actually, and it doesn't even have to be a model. Like, I actually found it useful to look through where am I getting the answers wrong. I think I get a good number of the answers wrong on this training set, so that at least not the first one, right? My first choice isn't always right. But just in general, looking for places where your errors are really big can reveal lots of interesting structure in the problem. So interesting structure in the task you're trying to solve. And it can also reveal issues with your data set. So mislabeled examples. There's a ton of great work on like mislabeled examples in ImageNet for like Sarah Hooker had a great paper about that that looked at mislabeled examples in ImageNet. And especially as people chase like really, really high accuracy levels, issues of like mislabeling or disputable answers become more like way more salient. You may recall from taking exams in school that you can often beef with the grading on whether an answer is right. So let's keep on going on this deep dive and look for places where the GPT 3.5 gets the wrong answer on a question. So this is gonna run it 10 times. Just grab like the first 10 examples and see whether GPT 3.5 gets the answer wrong. So it looks like there are 2 questions that it gets wrong. Let's check the code again. R equals, it's not some, I was looking at the output of this SUMM function. I thought it was a sum function giving you the total wrong, but it's actually just saying which instance was wrong. So we grab a row out here. I'm gonna maybe change the name of that R to row so that I can remember what it is. So we got a row. We have the response of the model, and the model's answer. So at this point, we're still just doing exploratory data analysis here. We're using a model to make our exploratory data analysis more effective. So you might be wondering, like, wait, why aren't we talking about prompt engineering? Why aren't we talking about the best way to prompt this model to get the highest possible performance? That's actually kind of antithetical to our goal here. Our goal is to actually find places where the model gets things wrong. So we want a decent number of mistakes, because we expect there to be information in those mistakes. So let's look at this question here. Which of the following statements accurately describes the origin and significance of the Triskeli's symbol? So the Triskeli's symbol, in case you're not up on this, let me grab an example of the Triskeli's symbol from a browser. The Triskeli's symbol, I actually thought, initially, I thought it was referring to the like 3 legs from like the Isle of Man. But the Triskelion is this like triple spiral thing. So I don't know if I'd call that a science question, but it's in our science question data set. And the model got it wrong. It said the model answered D, 3 interlocked spiral arms, an emblem for the rulers of Syracuse, usage in modern flags of Sicily due to the island's rich cultural heritage. Head of Medusa at the center represents the lasting influence of Greek mythology on Sicilian culture. So not sure that the Triskeli symbol in general has a Medusa head at the center, so that's maybe why that answer is wrong. But the looks like the correct answer according to our results is it's this reconstructed as a feminine divine triad by the rulers of Syracuse, having 3 headlands. And it also mentions the head of Medusa. So it's not the head of Medusa thing. This is kind of a mysterious issue. Not sure why our model's getting this wrong. And so at this point, Jeremy and I are in agreement. I have no idea whether the Kaggle response is right or wrong. I don't know whether the problem here is in my model or the problem here is in my data. So because we know that the data comes from Wikipedia, we can actually check it on Wikipedia. So Jeremy tried this with Bing, because Bing has a nice interface for both like looking at a web page and sending it to a language model, which is definitely a nice feature. It requires you to use Microsoft Edge, so I haven't used it very much. I'm just waiting for something similar to get implemented in ChatGPT or in another language model interface. So we're gonna do it. We're gonna do it in a slightly more manual way. We'll grab this Wikipedia page, and we want to try and find out whether the answer is in here. I think the substance of the difference between the two answers was talking about headlands in one answer versus talking about the feminine divine somewhere in the other answer. So just like one way to do this without going to a language model to answer the question is to just do some quick like searching in this Wikipedia page for terms that were in the two answers. And the language models are generally going to reuse the language from the, especially in the correct answer, they're going to reuse language from the Wikipedia page. So we might expect to be able to find it. So one thing jumps out at me immediately, meaning not recorded directly. So that suggests that the answer to this question is going to be very much up for debate if there's not an actual like meaning written down from the time that the symbol came about. Nice. It looks like the Triskelion is in fact the one with the 3 legs from the Isle of Man, so I wasn't as wrong as I thought. Yeah, so it looks like in this 1835 study, the Duc de Luynes noted the co-occurrence and reconstructed a feminine divine triad, which he identified with the triple goddess Hecate. So one thing that I'm noticing here, and that Jeremy also points out, is that this segment here is like actually just what some dude in the 19th century thought was the meaning of this thing. He's the one who said it was a feminine divine triad that is being represented by this thing. So we also see that little bit of headlands. The Sicilian Triskelies is shown with the head of Medusa at the center. So what I'm seeing here actually is that this Triskelies symbol, like this when it's, the answers here are like pretty messed up. That the the correct answer has something incorrect in it. The feminine divine triad by the rulers of Syracuse. So that's incorrect. So the language model didn't use its context correctly in writing this question. So that suggests this is going to be a pretty challenging to get the top, pretty challenging to answer these questions correctly if answering them correctly means mimicking what GPT 3.5 did, which may or may not have been incorrect. So that's one reason that you might want to be careful when picking your fine-tuning stuff. You might want to pick questions that kind of mimic these same issues that a large language model has. So you might want to generate data using like a similar retrieve from Wikipedia and write answers to questions strategy so that you pick up on large language models kind of like foibles and issues. So I did that a little bit manually. I'm actually kind of curious why this is even like a scientific symbol. I don't see the word science anywhere in this page when I control F for science. Okay. Occurrence in nature. The boric acid molecule is Triskelion shaped as seen in the image. So that's this image here. The molecular point group of Triskelion shaped models is C3H. The clathrin, the protein, is Triskelion shaped. So I guess there are some ideas in science that reference the Triskelion shape as a type of symmetry, this kind of like threefold symmetry. So I guess that's why it counts as a science question. So this is also going to suggest that I want like a very broad notion of what it means to be a science question when I'm training my model. These are the kinds of questions that it's going to get. So the other way, I think that so that approach that I just did was kind of manual. If you wanted to try and automate that a little bit more or speed it up with language models, you might use a workflow a little bit closer to what Jeremy mentions, which is getting a hold of this information, dropping it into a language model and seeing what the language model seeing what the language model says. That's something you could run on all of the questions, and like grab relevant Wikipedia pages, use a language model to decide which Wikipedia page is relevant, grab those Wikipedia pages, and answer the questions. So that's one. So that's, you can use language models to accelerate your work with natural language processing in lots of different places. I think you want to kind of go back and forth between using the language model to do stuff at like a big scale where you can maybe do some numerical analysis, versus doing stuff by hand, where by going through it yourself, you kind of uncover the these like subtle, hard to quantify kinds of patterns in your data set. And as with most things with data sets, like all the stuff we're talking about here feels like very specific to this like Kaggle competition. Oh, it happens to be using GPT 3.5, happens to be using Wikipedia. So all the stuff that I'm doing is like pretty tightly focused on the details of this data set. And that's kind of the way data is. Like data is always going to be like very, very specific. Models can be very general because models, are just like, oh, I have sequences and inputs and outputs, and there's only a small number of probability distributions we even understand, so we keep them relatively simple. But data is generally complex and very bespoke and specific. So I would take, I'm trying to focus as much as possible on the general things that are useful outside of just this science exam Kaggle competition, in terms of thinking about how to explore data, things that will also apply if you're building a chatbot, if you're building like some natural language processing unit in a feature in a software service. This should all still apply. So the Jeremy's able to get Bing to agree that the answer is like the Kaggle answer is wrong, and on the basis of its knowledge, so that's GPT-4, both without access to the Wikipedia page and with access to the Wikipedia page. So that's interesting. So I'd say I definitely, to close out this section, I definitely agree with Jeremy that using these like online large language models that you can just like quickly drop into, ask a question, very important skill for data scientists. I might actually, if we do more EDA, I think one of the things that I'll definitely do is try out the like ChatGPT code interpreter to do some quick code generation and some quick analysis to see a little bit of what that looks like. So yeah, I definitely do agree that, refusing to use language models to help with stuff is like refusing to use Google or Stack Overflow, just because sometimes blog posts are wrong and sometimes Stack Overflow answers are wrong. All right, that's everything I had for our data deep dive. Let's go into the actual part where we get the baseline accuracy. So, we're going through this like initial phase of I've been tasked with a machine learning problem, and what do I do? Step one, always get to know the data, get to know it really well, use whatever tools you can to understand the data. We're now at the point, then step two is establish a couple of baselines. If you jump immediately into trying to like solve the problem as best you can, you're going to run into not really knowing like what is good and what is bad performance. So a nice thing with Kaggle leaderboards is that you can compare yourself to a bunch of other people, and so you can see like what decent performance is, and the like bottom of the leaderboard, there's going to be a big bulk of people at some common baseline. So that does help. And that the equivalent of that in general outside of Kaggle competitions is that there's often related work that you can look at that says, typical performance on optical character recognition on this data set is 80% accuracy or whatever. So those external baselines are helpful for getting, for just having any idea what's good or bad. But more useful than that is having a baseline that you can run yourself, like a reasonable baseline, not like some horrible baseline, but a reasonable baseline you can run yourself, so that you can maybe apply, if you come up with a change to improve your model that's like way more complicated than your baseline, you can also add it to the baseline and see, sort of adjust your baseline, move it up and down over time. You also never know whether you can trust people's results that you read in the literature, and so if you're not running them, then it's much harder to trust them. So the baseline that Jeremy suggests is just using GPT 3.5 to answer the questions. So that sounds like a good baseline to me, and to do that, you might naively think, oh, why don't we just for loop that code that we were just looking at that runs the language model on a prompt. Language models take a couple of seconds to respond via the API, and that's not so bad when you're in some like live loop yourself. But when you're running something like, when you're running code, a few seconds is like a very, very long time relative to like most things that we do with computers. And so you would think, oh, that means I have to wait like 70 seconds to answer this like 20 times. But because we are just sending requests to an external service, that's something that we can do easily with concurrency in Python. There's a couple different ways to do it. Jeremy chose the thread pool executor from the concurrent part, I think, that looks like the standard library. So this little thread pool executor just kicks off basically a bunch of different jobs of kicks off a bunch of different jobs to send these send our questions to the language model. And this so just let me maybe break this, split this code up a little bit. It's was pretty terse there. So we're gonna run our checking code on a particular example from our training data set. So training dataset.loc, this particular one. So I might call that actually I'm not sure whether that's not an index. So oh yeah, maybe it is an index. It looks like we're sending in an index to this thing with this map. So we'll call that index to make it clearer what's going on. TRN, that's our training data set, right? So we're running check on each row of our training data set, and how we're doing that with this thread pool executor, 25, num threads is 25. So just make that a little bit clearer. And then we're doing it for all of the examples. So I think there was, we'll go ahead and just run this. One thing you want to watch out for when you're querying external services and using concurrency is, wait a second, how much is this going to cost me? I definitely once or twice ran just once, ran a really, really big concurrent job on GPT-4 and blew through $100 of OpenAI credits. And then I learned to be a little bit more cautious. So I'm actually going to, in fact, be a little bit more cautious here and grab something from later in the notebook from Jeremy, which was just this little snippet for getting the actual costs. Sorry for scrolling really fast. So let me go all the way back up here. and then put that in. So this is, we want to do a quick check of how much it's going to cost us to run this cell here, given that we are about to, given that we're about to query this external API. So the number of conversations that we're about to run is the length of our training data set. And I'll print len train to make sure that that's true. That should be 200. Great. And then words per conversation. This is like how long are these things? So let's check churn.prompt. And let's grab just one row. Let's grab one row and let's see how long these things are. So like the expense of running a language model depends on how much text you send to it. And that's calculated using tokens, which not tokens like crypto tokens. Tokens here means some collection of letters. Usually it's like a whole word or a large fraction of a word. So we'll just pretend that it's the number of words. And so we'll grab, they often have a white space at the beginning, so they kind of like separate out like that. So we can estimate the number of words in something by, estimate the number of tokens by like first pass, just like looking at the number of words. So we, let's grab, let's see, row.prompt. We got that guy, and then we can split it on space, and then we get len of that prompt. And then we had that check one. This is the code that we're actually sending. We're prompting the model with prompt one. So let's check and see, does prompt one add any stuff? It adds a couple of things. We could maybe just, actually a good way to check this, rather than trying to figure it out ourselves by like adding together, by like reconstructing this prompt, let's do prompt one row and then dot split space and look at our len. Okay, great. So this is roughly the size of something that we're sending each time. Is like 100 is something like 185 words. Another one is 200. Let's check around 180. So we're getting like fairly consistent results in like a couple of examples. If we really wanted to get it, we might do a mean here to say like what's that'll give us an actual value. But we're just trying to get a rough example. So let's be a little bit pessimistic and let's put it at like 225, which is kind of on the high side for those couple that we saw. And it looks like it's going to cost us 10 cents to run this thing. So keeping around something like this for cost estimation isn't a bad idea. Definitely a lot of language modeling libraries will include cost tracking. So you can send a query and see how much it cost you. So that's another way to sort of like watch this. Not sure which ones include cost estimation, but definitely cost tracking is in a lot of language model libraries. But yeah, so it looks like it's going to cost us 10 cents. So not going to break the bank. We aren't going to spend like $100 on the OpenAI API. So let's go ahead and run this code. And it should, we're running 25 things concurrently. And then there are 200 examples in the data set. So we should probably expect about like 8 times the typical length. So 200 divided by 25, and then is 8. And the typical length is a couple of seconds. So 8 times that, we would expect this to take maybe 30 seconds to run. So we'll see. I think Kaggle notebooks by default do show you how much time it takes for something to run. Oh, maybe not. I thought they did. I guess they track time up here, but they don't show you the time. So if we wanted to, we could add like a cell magic, like percent time up here, percent time, if we wanted to actually track that. So if we ever run it again. we can figure that out. The other thing is, yeah, saying that it would just automatically parallelize. I know it's 8 times the typical length is probably, yeah, that's overly optimistic. Some things are going to take longer than others. Some requests, there's more tokens, so it takes longer for the model to respond just because it has to do more processing. Sometimes you get caught in line at when you're querying an external service, even if it's one that you're running yourself. If you have a large load, you're going to have to like handle, batching, holding on to jobs for a while, creating a job queue. If you're running Llama inference yourself, so you'll see the same phenomenon that some requests take longer than others, and you'll want to be tracking and paying attention to your 50th percentile latency, your 90th percentile latency, and you'll observe that a large fraction of the time that you end up waiting ends up coming from those 90th and 99th percentile queries. So yeah, I think it's been longer than 30 seconds already at this point. So that naive estimate was wrong. So fingers crossed that it finishes in a reasonable amount of time. We can keep going here and rely on the fact that I already ran this notebook, sort of cooking show style. We already have results here. We don't have to necessarily wait. So the first is that when I ran this previously, I got about 30% wrong answers. That's also what Jeremy reports for his example. And when I ran it, all of the responses fit the desired format. The response in the response had a letter of A, B, C, or D in its response. Definitely at least once Jeremy saw an answer that was like the correct answer is A instead of just A, but that didn't happen for me. So there's some stochasticity with these language models. All right, how are we doing on this? Man, that's taking a long time. Could be, yeah, traffic jam in the OpenAI API. All right, let's keep going and checking this out. So we have our baseline, and the baseline was pretty, we didn't think that hard about prompt engineering. So the prompt was just this, question answer. And that is okay if our goal with the goal with the baseline is really just like what the hell is going on here, then we don't have to go any further. But it's maybe helpful to establish a strong baseline, if you're using this to try and determine what your modeling choices should be. Having a really strong baseline can focus your efforts. Like most of the things you try aren't going to beat the strong baseline, so that'll maybe cut off some dead ends in your modeling process. So let's make so what Jeremy does here is make a stronger language model by coming up with a better prompt. And the most important thing about prompting language models is to recognize that the autoregressive style here means that like they generate these tokens sort of like one at a time rather than generating like a whole bunch of them. There's a couple of different things here. One is like if the model generates a bad token at the beginning, it's often going to get kind of stuck with the in a bad situation. So you want to make sure that the first couple things the model generates are good tokens. And the other thing is the like class is is that if you give the model the opportunity to generate a bunch of tokens, it is able to like do a bunch of calculations while producing those tokens, and that is effectively giving it like time to think about what the answer should be. And so this can get like you are going to end up with longer latencies and more cost if you do it this way, but you'll get much higher quality results. So this is like tuning the amount of time that you spend, the amount of time you give a language model to think can also kind of can be a way to trade off latency and accuracy. For different applications, you might need really low for one application, you need really low latency because you're like, in somebody's developer environment, or you're in like a chat situation where people want a response immediately. Others, you might be able to tolerate a really high latency. And you, so like, for example, you're doing PRs to their GitHub repos. It's okay for that to take a couple of hours, so you can really like take the time to make sure the model's right. So this one, since we're just establishing a baseline and we aren't worried too much about latency right now, that's not super relevant. All right, how are we doing on this? A little worried about this thread pool executor taking a really long time. Let's cancel the run and see where we were at. All right, at least looks like maybe we had at least one. I'm looking at this error message here. I see that we are at the point where the threads are being joined. So that's when we, finish up and all of them are, all of the threads are supposed to be finished. And so if even one of them has run into an issue and that issue is not like bubbled up or handled correctly, then we can end up blocked there. So that could have just been an issue with the, like, say, the OpenAI API. Let's just do like a much smaller number and hope that that responds more quickly. If I don't get a response in like just maybe 10 or 15 seconds, I would stop this one. Okay. Yeah, it looks like we hit some, with external APIs, you always got to worry about running into issues like that. Yeah, that's also a good reason. So right here, we're like implementing our own concurrency. We're saying like, oh, let me grab this like thread pool executor from the concurrent library, concurrent part of the standard library. That's rolling it yourself. You're like likely to make little mistakes. It's like better to use a framework. So frameworks like LangChain, like ICE, these have built-in better approaches to asynchrony and concurrency. So we'd be less likely to run into a problem like that if we weren't rolling it ourselves. All right. So, all right, now we've got our kernel back. We're no longer stuck. So this part is a little bit about how to use that LLM library. When you're making a conversation, it stores information over time. So you can send message after message. And for example, it will like remember, in this case, it remembers my name when I follow up. If I like start a new conversation that disappears and I run it here, do you remember my name? I apologize, but as an AI language model, I don't have the capability. And then I can keep this conversation going, and now the model knows my name. All right, so we've got this with this conversation one. All right, so what we want to do in order to test this one, to test this approach of like giving the language model more time to think, we want to find an example where the data set's correct, but our model gets the answer incorrect, to see if the new approach fixes it. So this is another thing that you do in your sort of like exploratory data analysis. You kind of like mine for these like hard examples, and you kind of collect up examples that you can then fix. It's sort of like collecting examples of bugs from people interacting with your library or application, and then adding them to your testing suite, right? You might add an example of like, a user reported that this method crashed when you crash the program when you put in a none for one of the values, and that's not the behavior that you wanted. So you add a test where you put in none and see if the program crashes, and it shouldn't once you fix the bug. So the equivalent to that for language or for using ML models instead of traditional software is to find examples where the behavior is incorrect, and then keep those around in your testing suite, or in some like special data set, and run the model on those examples and see whether check whether the behavior regresses, see whether you can fix that behavior. So this is an important part of building a data engine, as Karpathy describes it, or a data flywheel. So this question is about resistivity, which is similar to, but not quite the same as, resistance. Resistivity is this intrinsic property of a material, as mentioned in this correct answer. That's about how difficult it is to make electrical current flow through something. It is it's an intrinsic property because it doesn't depending on how much of the material you try and flow through, you'll end up with a different resistance. So you might have seen, if you've ever played around with electronics, you get resistors with different resistances, and that might be the same material with the same resistivity but different lengths. So that's the distinction here, and the model got the answer correct the answer incorrect with the previous prompt, and it answered and pretended that resistivity was the same thing as resistance, and said it was dependent on the material's shape and size. So let's try just doing a sort of more let's think step-by-step style in a conversation. So this is also something you can totally do this in like the chat API. So we could go over to like a chat.openai and run it there. One thing that's nice about this LLM library is that you can do a lot of those kinds of interactions from a terminal or from a notebook. Oh, somebody in the chat, Raceman100, asked about this LangChain alternative ICE. I would say it's not quite a LangChain alternative. It is it's also like kind of a framework for using language models. It's more focused a little bit on tracing. So it's focused maybe a bit more on the stuff that Langsmith, the like tracing library on separate from LangChain, does. That's ICE Interactive Composition Explorer, and that's from OUGHT. OUGHT. All right, so we've got our response from our model, precisely and fully describe the answer to the following question. So the difference here is we're prompting the language model to actually write its thoughts out first. So it's writing a bunch of stuff about this. Some of this might be incorrect. Haven't done any, electrical calculations recently. Back when I was a neuroscientist, I had to think about that sometimes, but not so much these days, working with neural networks instead of brains. But yeah, so we've got an answer. It's longer. Let's see whether that whether now sending the question to the language model after it's just written about it, written its thoughts down, and whether that improves the quality of the answer. So now we're keeping this conversation around, and now we're sending in the question, and seeing if the model gets the right answer this time around. We also changed this part also changes the what the model's asked to output. So in addition to having that context, it also is first going through the options and explaining why an option is or isn't a good description, then outputs a summary that's like, overall, which does the model think is most accurate, and then finally output the answers. So this is also, interestingly enough, like kind of similar to the advice you might give somebody who's struggling with test taking. They're like, oh man, like I feel like I know it, but then when I sit down and I take the exam, I like get the wrong answers, and I'm like kicking myself afterwards. The advice that I would give, like there's a bunch of different strategies, but one of them is definitely to go through each of the options and sort of like write a little note next to each one before picking your final answer. So lots and lots of intuitions for how to be better at tasks as a person, also work for making language models better at tasks. especially like instruction tuned models like, Llama Chat and the chat versions of GPT. Okay, so long answer from the model. It's like writing out each of these options, talking about it, providing its summary, and it is now answering that the most accurate description is option C, correctly identifying it's an intrinsic property, correct unit of measurement, emphasizes that resistivity is independent of the material's shape and size. So one thing to note is these chains, this like chain of thought reasoning stuff is not always reliable. Like this might not be the way that the model is actually coming up with the answer. There's a good paper that shows that if you force the model to answer the wrong thing, it will come up with if you force the model to actually use a like cheap heuristic to answer the question, like the answer is always A, instead of saying, oh, I know the answer is always A, which a person might say when you ask them how they got the answer to a question, the model will instead make up a very plausible explanation for how it came to the answer. So definitely like be careful about relying on this in any sort of really like situation where it's really important that that description is accurate, because it's very hard to trust those descriptions. And yeah, so yeah, the conversational interface is nice. It's like hard to turn something like this very fluid conversation into an actual way to run the language model in when you're actually answering the questions. You could try writing a language model to like come up with these questions on the, these follow-up questions or this conversation on the fly. So that's definitely an option. You're really gonna blow up your language modeling bill if you do that, but you can do it. But yeah, so to use this conversational approach, rather than including like a more complicated like follow-up back and forth, like some sort of like Socratic debate, the folks at Anthropic really love that style of getting language models to be better. And it kind of shows with Claude. Claude can be like pretty smart, pretty good. Anthropic's model, Claude. Yeah, rather than doing all of that, we're just going to do a very simple fake conversation where we first send in the question, ask the model to just answer it based off of its knowledge, and only then pass it the multiple choice version. And ask it, still ask it to do some follow-up and stuff before putting out that last line that has the model's answer to the question. And the results are generally pretty good with this one, I would say, like especially on this particular example where the model got it wrong. So this is where the issue of cost comes up. So this is where I copied some code before to use earlier to check costs, where we found that it was like super cheap to run our previous one, like 10 cents to run it on 200 examples. All right, yeah, looking like we get the right answer of C, and all the answers are there at the bottom. So the response is longer. We're calling the API twice. So this one's more likely to cost more. We can check how long that response was. Do we keep that around? No, we didn't keep that around. Bummer. Let's call this response 2. And let's run it again, keep that around, and do our quick response 2.split word. You can also, if you want a tighter check on costs, you can also run the tokenizer to actually check how many literal tokens you're sending or receiving from OpenAI. But usually you just like an order of magnitude or a rough guess is enough to serve your purposes for like estimating whether something's going to be really expensive or really cheap. Okay, so response 2.split. So we have about 350 characters in the response. We know that there's like about 200 or so in the 200 or so words in our questions. So we know we're already at like a little bit over 500, maybe 600. And then there's also the model's initial response. So the rough estimate that, and probably pessimistic estimate that Jeremy goes with here is 1,000 words per conversation, which gives us a total cost of about 40 cents to run it on everything. All right, so once again, we're doing that like thread pool executor thing to run this on a bunch of them. I'm gonna again kind of cut this down to like 100 examples, and I'm gonna leave leave a smaller thread pool. You might be wondering, like, why not just boost the thread pool executor to 200 and run all of these at once? The answer is that the OpenAI API has like rate limits on the number of queries, which we probably wouldn't hit because we're just making like a couple hundred queries, but also rate limits on the number of tokens that you can send. So if you send a small number of queries, but each query has thousands of tokens in it, then you can hit the token limit as well. So that's a reason to not just like fully parallelize it, and just send one at a time. But send one at a time, but all at once. So we'll get the responses out from this, and see how it gets, whether it gets better, but that might take a little bit of time. So let's keep going. So in order to with this one, we're now like trying to establish our baseline. We're going to get like a little bit closer to actually scoring it the way that the model is scored in the final evaluation, which we talked about towards the beginning. But your goal is to output in your first 3 answers. You want to output the correct answer in one of those top 3. So the model outputs like a ranked order of the answers, so it puts its favorite answer first all the way to its least favorite answer. And one thing that can go wrong is the model can sometimes not. So that's this first regular expression here, is checking whether the model answered exactly the 5A, a character between A and E 5 times. So that's what this first one checks. And if it matches that, we just return it. Otherwise, the model has done something wrong. The most common thing it does wrong is it doesn't give the 5 ranked answers, it just gives one, its favorite answer. And then if that's the case, then we just repeat that answer 5 times. And if it didn't do that, it did something else, like it said, sorry, as an AI language model, I can't answer questions about plutonium or whatever, then we just return A, B, C, D, E. We give this is just like some worst case scenario default response. So that's how we turn the output of the language model into answers. I think definitely the better way to do this these days is using the function calling API for OpenAI. Have the model create a function call where the parameters are things like top answer, second best answer, third best answer. And even if you don't pass that to some downstream function, you've now got the model to output structured JSON that you can easily parse. And the models are pretty good at complying. Actually, the models are, as far as I can tell, like basically perfect at complying with that kind of schema with just like a few fields in it. They'll always output something that is valid JSON, so it's easier to parse maybe than writing your own regular expressions, and you might get better results too. So that's one possibility for how we might improve the results in this notebook. All right, let's run our scoring. So it's run. So this section on scoring the answers actually says the Kaggle evaluation metric gives you a full point if you get the answer right with your first guess, 2/3 if it's your second guess, and 1/3 if it's your third guess. I actually think that's not quite right. We can go back and check that in a second once we've run this scoring thing. But assuming this is the scoring metric where we're checking where we're giving partial credit for answers that are not in the top three, or sorry, partial credit for having the right answer is second best or third best, then our score is like 78%. This does decently on the leaderboard in the competition, at least at the time that this notebook was written, like earlier in the week. This isn't a way to solve the Kaggle competition because there's you can't call internet APIs in your submission, but it at least says, all right, you could, if you were able to mimic GPT 3.5's capabilities, then you could do decently well in this competition. And the best current open source models, like the 70 billion parameter version of Chat Llama 2, it seems to have similar levels of capability to GPT 3.5. Definitely people have been fine-tuning on top of Chat Llama 2. Evaluating capabilities is pretty challenging, so it's hard to know, but saying similar is probably fair. So you might get less than this, but not 30% instead of 75% score. So you could look at this and say, all right, if I have a path to achieving decent performance on this, getting onto high up on the leaderboard, I just need to get Chat Llama 2 running, and maybe I need to get it running on the resources that Kaggle provides. So maybe I need to distill the 70 billion parameter Chat Llama 2 on this problem onto the 7 billion parameter version, something like that. So that suggests some paths forward for solving this. We've also talked about ways to improve the data as we're going here. So that establishing that baseline, even though it's not what we're going to actually run with, has helped us get a clue of what we might do to actually solve the problem. And in outside of Kaggle competitions, where there's maybe a restriction on things like calling an internet API, it's also sometimes when you're working on a baseline to solve an ML problem, the baseline is good enough and you just run with that baseline. That's always a nice thing to see. If you can turns out you can actually just deploy a simple rule-based system or logistic regression in production. That's always a great thing to discover. It's a lot cheaper and a lot easier to maintain, maybe easier to even improve over time than an ML solution. All right, so we've got our baseline here. We've made it through down to basically the bottom of the notebook here. So at this point, we can take a couple of different directions. So we could do more exploratory data analysis. So we could grab this data set, go into, I would say, the GPT-4 code interpreter, and use the code interpreter to kind of explore the data a little bit more, figure out what the topics of the questions are, for example, estimate their difficulty. We could just do some minor adjustments here, use GPT-4 and do some more prompt engineering to improve the results. We could try the OpenAI function calling API to improve results, as I suggested, where we would you write down a little schema for a function, pass it to GPT 3.5, and then its response, instead of being text, becomes JSON. That probably won't improve the results very much, but it might be interesting to see. The folks, looks like there's maybe a dozen folks who have been watching for a while and following along. If folks want to suggest in the chat which of those directions would be most interesting, EDA, GPT-4 and prompt and a little bit of prompt engineering, the function calling API, whichever one. I'm happy to try one of those in the last, maybe, looks like we got about a half an hour left before I have to close out this stream. I don't have any particularly strong opinions. I think I've definitely enjoyed doing EDA with the interpreter, but it doesn't have to be that one. The function calling API is maybe the most generally useful one, even though it's not going to give us better results. Waiting a little bit now because there's a bit of a delay before anything shows up in the when I say it and then when it gets sent out to y'all. So giving a moment for people to think maybe about their answer as well. Oh, interesting suggestion just came in from Jonathan Whitaker. Maybe you could look at generating some training data. That's an interesting suggestion. So what would it take to generate some training data? To generate some training data, we would need to pull down some things to ask questions about. So we would need a collection of things to make questions about. And then we would need to know what the right answers to those questions are. So that's going to be the bottleneck, I would say. Once you know the right answer to the question, it's pretty easy to generate the extra multiple choice ones. And a follow-up suggestion from Jonathan Whitaker, seeing if you can measure how well the data matches the style of the competition questions as closely as possible. Yeah, that's an interesting one. Right, so the hard part is getting questions with correct answers. So maybe we can just like slightly crowdsource that a little bit. Maybe suggest some science questions and give me the correct answer as well in the chat here. And we'll turn that into some questions. So I'm gonna drop down here. I'm gonna start writing some of the relevant supporting code here while that's going on. So we got our model. We have model.prompt to send information to it, and we are going to let's prompt it with system message. You are an expert at science trivia and always give the Wikipedia same answer as Wikipedia. So just adding a little system prompt there, make it answer questions a little bit more in the style that we're expecting. Also, while I wait for people to think of maybe some science questions to ask, we can grab our prompts, and actually what I want is the answers, because those are the ones that we want to mimic. So grabbing train.a, let's do train.a.map len. No, we need a little lambda here. We'll take a string, and we will take that string s dot. I just want to know how long these things are. How many words are this? So we're looking at trying to generate data that matches this style. So what's one aspect of the style? Just length is part of the style. Train.a.map lambda s.split. And then we want len of that. This is the same thing we've been doing in a couple of other places to get that like approximate length. And then we'll use a nice little pandas function, describe. So average of 25 words, standard deviation of 16, so pretty big. Oh wow, minimum of 1 word in a response. That's pretty wild. That might be a data error. We should check that out. All right, so let's try that. Let's do len A's. Is that without the describe? Len A's sort values, pandas. Okay, so we got a couple that are only one word according to this thing. So let's do and we have their are their values, their indexes are there on the left. So len A's dot sort values dot index. That's our index here. Let's grab the first 5 of them and let's check. I think you can just pop that bad boy in there in pandas. No? Oh, right. We want to index locate stuff, not regular locate stuff. Okay. It looks like there are a number of answers that are very short relative to the previous ones. So these, where it's just like a name, a number, like a single concept. Looks like there's a lot of correlation between the length of the answers, though, which is interesting. And then let's look at some of the longest ones. The longest ones look a lot more like those answers that we saw at the beginning, where it's like they all have kind of like a similar format to them, but slightly different information in them. Yeah. Okay. Okay, yeah, so suggestion from Jonathan Whitaker, maybe steal some questions from the training set as examples if we're not able to get any, crowdsource any from the chat. Yeah, maybe what I might do is like, just to cheat a little bit, there is a Science QA data set out there. The Science QA dataset has their multimodal questions, which is a little bit annoying, and downloading the data would take a minute or two, like just like getting a hold of it. So what's the, can we generate example data? Oh, yeah, I mean, the simplest way to do it is to just regenerate the wrong answers from the training set. So let's see, let's say generate wrong answer given a prompt and a correct answer. So this is like closer to the way that the thing was actually run. So we're going to have a we'll say that this is a question rather than calling it a prompt. And then the prompt is going to be something like this, say F. You are writing a science exam on general science knowledge. Here's one question and its correct answer. Generate an incorrect answer to be used as a multiple choice alternative. Multiple choice alternative. And then I'm just gonna borrow a trick from the folks at Elicit. So I put a little space at the beginning there. This will remove that. I can also put spaces at the end and I'll remove that. So let's do incorrect answer, colon. Actually, so we're prompting a conversational model here, GPT 3.5 Turbo, so we actually don't need to do any of those prompt engineering tricks you might think of where it's like, start answering for the model. So let's generate a wrong answer. This way, let's see, we are going to, what do we need to do to finish off this function? We have a prompt. We have, we would want to say like model.prompt. Okay, we won't use that system prompt that I was thinking about there. Let's see if generating the wrong answer works here on just like a single example. Let's take that first one, which is the modified Newton dynamics question. So what do we want to do? Oh yeah, we definitely want to finish writing this prompt as an F string. Yeah, so we want question Q, answer A, and then correct answer. Maybe put a space between them. All right, so let's see if we can make, if we can actually make a good example. So generate incorrect answer. Actually, I don't love that modified orbital Newton mechanics one. So let's find one, because I don't or maybe it wasn't orbital Newton dynamics, but whatever. That's not one that I feel like I know super well. So let's try, I think there was this summary function that, that gave the model's answer here. I just want to look at examples until I can pick one where I think I would know what the right answer is. So let's do the prompt and the right answer. Row good for sample I. Print row dot prompt, and then print row option or option in A, B, C, D, E. Yeah. And then print row dot answer. Look through this thing. Print, row dot prompt. Oops, meant to put sample 1 here. So that's a easy way to get a single result out of pandas.sample. Indirect photophoresis, spinning superconductor. Oh, that's timely. And the answer is a magnetic field precisely aligned with the spin axis. That would be the flux pinning that supports levitation. So that's, I feel like I get that one. Let's run with that one. And, forgot to print the ID. But luckily I still have the row around. I would definitely have wanted to print row ID and then prompt. But, okay, so 70. All right, let's see how generating a wrong answer goes. Generate wrong answer. So definitely I will want to fiddle with this prompt to improve the quality of these things. It's hard to figure out how to evaluate the quality of the model that is generating our data as well. I think that we're reasonably close to the way the actual underlying data was generated. So the closer you can get to the way the underlying data is generated, the less you have to worry about evaluation. You don't necessarily have to evaluate data when you collect it. So that can make things easier. But in this case, we aren't perfectly aligned. So you might worry about whether we're, are we getting the best possible data? But let's put in row.prompt as our question and row.answer as the answer and see if we can't generate a nice wrong answer. All right, so generate an incorrect answer to be used as a multiple choice alternative. Text B photoluminescence. Okay. right, let's see how this goes. Incorrect answer, D, increased friction and resistance. Okay, so we want to give, so the first thing I'm noticing, we're not getting good, like, consistent formatting from the model. Like, it looks different each time because we're in a chat interface and formatting doesn't usually matter when you're in a chat. So let's kind of change this one. It looks like, interestingly enough, the phenomenon or the like main thing that I'm noticing here that's different about my answers versus the answers that are in the test data or the train data here is that the answers that are coming out here are much more varied. They're much more different from the correct answer. Oh, it looks like, the correct answer here, I just put C. That's a problem. So we've got I put the letter of the correct answer rather than the actual correct answer. So what we want is row dot answer. That should be the actual correct prompt. All right, a magnetic field precisely aligned with the spin axis. All right, so we still have the problem of like the formatting possibly being different from time to time probably. So let's keep running it and seeing. Electric current flowing in the opposite direction of the spin axis. Electric current flowing in the opposite direction of the spin axis. It likes that one, definitely. A gravitational force causing the superconductor to levitate. Interesting. That's definitely incorrect. Because you can't just like spin a superconductor and it starts levitating. So yeah, that's another good incorrect answer. All right, so yeah, it's not doing so bad. Let's do a little bit of like tiny prompt engineering. Generate incorrect answer to be used as a multiple choice answer. Make sure the incorrect answer is still plausible, so that it's actually testing knowledge. Please only respond with the text of the correct answer. Nothing else. That'll hopefully make our lives easier. All right, so electric charge opposite in direction to the spin axis. Generation of electricity. Some of these might be true. I don't think it generates electricity, but all right. Looks like the formatting is pretty consistent now. It's consistently putting a colon at the beginning. Yeah, so maybe we want to make sure that let's see, a colon. Incorrect answer. Just sort of a way to suggest to it the format. There's lots of different ways to do it. Unfortunately, you can't use curly brackets immediately with F strings. Yeah, a incorrect answer, nothing else. So just put in let's even just do that. It's probably the easiest way to suggest the format to the model. All right, an electric field perpendicular to the spin axis. That's actually, yeah, precisely aligned versus perpendicular. That's actually a nice challenging one. So the question is whether this is going to generate answers that are similar to the style of the questions in the training set. So yeah, if we wanted to figure that out, I think the easiest thing would be just looking at the lengths. That's not going to be a total answer to that question. I think the more interesting one, I think, would be like an edit distance or an embedding distance for the answers. Like how edit distant are the answers in the training set from each other, how edit distant are the ones we're putting together in our fine-tuning set from each other. Are we mimicking that? Maybe we want to make them, maybe we want a greater variety of edit distances or embedding distances in our training set, so that, you know, just in case the test set looks different from the training set, it might be good to like train on a much broader variety of data. So you don't always necessarily want to just match the training set. I think that's a common mistake to make if you're thinking too much in terms of just like evals and not in terms of like learning generalizable things that last through distribution shifts. All right, so we're generating wrong answers here. We've got a decent lead on thinking that this is on a method that we think might work. So let's see. Let's do generate alternatives for a row. So we're going to need to call generate wrong answer 4 times to generate our alternatives. Let's say that our alternatives is a list of generate wrong answer. Let's see, raw alternatives is going to be generate wrong answer for I in range 4. 4 is a magic number. It's how many possible alternatives there are to the right answer. And then we have row.prompt and row.answer as our things here. So this isn't going to be a very robust way to generate data. For one, we definitely want to make sure that we don't generate the same wrong answer multiple times. So we would want to like kind of re-roll when that fails. We would, and you might want to like incorporate, so you might want to say incorporate the previous incorrect answers into the prompt in order to avoid that. That also might be part of what gets the like greater uniformity between answers that we've observed in some of the examples from the training set. So that might be a different way to do it. It's like it's harder to parallelize if we wanted to parallelize it, but we aren't doing that yet, so that wouldn't be too hard of a change. We also need to parse them, so parsing can also fail. So we would want a way to handle parsing if we wanted a real robust data generation thing. But let's we'll leave those as to-dos for later. So raw alternatives. Then our alternatives are going to be like parse wrong answer. Raw alternative. And then we'll return the alternatives as a list. And for like parse wrong answer, raw, we'll take that guy and we will return, it should just have 3 characters at the beginning, :space. So I think I'm actually just gonna do the very dumbest parsing imaginable and just grab the suffix from 3 to the end. Great, so that's minimum version of this. Let's run it on our example row, generate alternatives on that, on our sample row. Did I just call that row? I did just call it row. All right, generate alternatives row, raw alternative, right, for raw alternative in raw alternatives. I don't use Kaggle that much, so I haven't set up like an IDE type environment here that would help me not make silly mistakes like forgetting to define a variable. Response object is not subscriptable, right? So if we look at the type of this thing, well, do I get type hints? No type hints, bummer. So we want wrong answer dot text, I think. Let's check. Generate wrong answer. Wrong answer equals this. We'll still return it so we can take a look at it. And then wrong answer dot text. looks like that's in fact the thing that we want. Oh, not, it's a method, not a property. So .text, and that's the thing. Okay, so .text, right. Yeah, response is not subscriptable. You know what? The parse wrong answer shouldn't know anything about where things are coming from. So I think I'll actually just slight refactor what I was about to do. We take the raw alternatives that come out. We do the text there. That seems cleaner to me. And then alternatives there. So it'll take a minute to run because we're doing 4 language modeling calls. And then we'll take a look at those returnatives. Electric field. Okay, so we ran into one of the problems that I suspected we might hit, which is like the wrong answer appearing multiple times. So that's a bit of a bummer. That's probably going to hit us multiple times. Row dot prompt, row dot answer. Okay, so I think we're going to have to actually build up the prompt over time. Maybe I think we should just ask for 4 answers at once and then handle the parsing afterwards. So you're writing an exam on general science knowledge. Here's 1 correction and its correct answer. Generate 4 incorrect answers to be used as multiple choice alternatives. Make sure the incorrect answers are still plausible so that the question is actually testing knowledge. Please respond only with the text of the incorrect answers, like this. Nothing else. Make sure answers are on separate lines. Okay. So that'll generate 4 of them, and I think I'm trusting the language model to have the context required to know that it shouldn't give the same wrong answer multiple times. All right. So then, all right, generate wrong answer. We can, yeah, and we should really call this probably generate wrong answers instead of generate wrong answer. Changed the behavior of the function. Semantics changed the name. Wrong answers. And then let's print answer or answer in wrong answers. Answer in wrong answers. Right. So it's not actually split. So I'm getting character by character there. Let's do print answer for wrong answers dot lines. I want to say that's the name of the function. No. Oh, it's wrong answers dot text. And it's a method, and it's not lines. It's just, I think it's just dot split. Okay. All right. So we've now got 4 alternative answers here. Gravitational force, electric field repelling charged particles away from the superconductor, sonic wave creating a high-pitched sound when the superconductor spins. Now, I'm going to say these are definitely worse answers than we're getting. We're getting, like, these are easier to answer because a lot of these are just, like, very implausible. But such is life. It can be challenging to mimic a data generation process, even when it just involves machine learning models. I'd say they mentioned also throwing out easy questions, so I bet, like, including in the prompt that these should be actually, like I said, that they should test knowledge. You probably want to, like, prompt it to be harder. Ask really hard questions or something like that. So let's do. So we won't do that, but we'll just keep going. So we're gonna optimistically assume that we can split on new lines to get our 4 alternatives. Alternatives are parse wrong answer alternative.text. So yeah, nice. Dot split n. Now we no longer need that, and we don't need to change parse raw answer. Generate wrong answers. Dot text dot split. Okay, raw alternatives is a list, and great, generate alternatives. Now, you know, this is not that different from what we just ran, but checking that putting it all together worked well. All right, so we got we got alternatives there. All right, so now let's run that on a subsample. Let's sample a fraction. Let's grab a quarter of the examples. So we don't want to do all of these. So subset train.sample. And now I don't care about being able to check whether the answer is correct anymore, because I just want to check whether we're generating things that are similar to the wrong answers, or the answer types. So what do I want here? Let's see. We got, we're going to want to add these alternatives to the training, to this data frame. So then we want, so let's see, the cheap and dirty way to do it would be to do it with the pandas like apply method of a data frame. So we're actually pretty close with generate alternatives for row. The last thing that we need to do is come up with names for the columns, I think. So add alternatives is really what we're doing here. Row, and then we're going to, we don't really care about hiding these things, so we'll call them like A1, A2, A3 or something like that. And so the alternatives equals generate alternatives, right? Isn't that what I called it? Generate alternatives row, and then for alternative and alternatives, we're just spend a lot of time on Plum and Code with language models, which is why it's nice to have something like Copilot by your side when you're writing this stuff, which I haven't figured out how to add something like that in Kaggle notebooks. I'm sure there's a way, but alternative and alternatives row. Oh yeah, and we want to enumerate them. II in enumerate alternatives. Row A underscore II equals alternative. All right, so that should work with df.apply. Let's grab just one of them, subset.iloc. So I'm grabbing just one. This is of type data frame. That's what I changed there when I went from .ilog0 to .ilog0:1, switched over to a data frame instead of a series. Want to make sure that this works. We want to go row wise, and I think, yeah, we want. Got to check again. I'm pretty sure that in pandas, the default axis is to go along columns. Oh no, objects passed to the function are series objects whose index is either the data frame's index, x equals 0, other data, yeah. So rows, or the data frame's columns, x equals 1. Okay, great. So iloc01 dot apply add alternatives. And just to keep things as consistent as possible with what we've done so far, I'm going to switch that to the ID of the superconductor question that we've been using. And apply add alternatives. Right, so it doesn't return. Yeah, actually, wait. Do you change things in place with apply? iloc 70 to 71 is nothing. Uh-oh. Oh, you know what? I was doing iloc on the index, and we're looking at a subset which doesn't have all of those. So that's why we're getting empty rows here. So nice to see that this code works on empty examples. All right, but looks like it failed in the case where I actually used it. Series object has no attribute prompt. That's interesting. Turn to iloc 70:71 index. So it should be, yeah, that's interesting. Let's just pass the little identity function in there. Dot apply lambda x. Dot apply lambda x. That is returning the whole data frame as the final result. What if I just do x.prompt? Series attribute. Okay, so now what I'm doing is I'm just kind of like examining these things because I'm forgetting a little bit how they apply at the level of data frame thing works. You know what? It's that we are getting things on the wrong axis. Axis equals 1. Yes. Okay. So this is what I really wanted. I wanted axis equals 1. Man, the pandas docs are pretty confusing. I looked directly at them and thought I'd figured it out. Okay. And then, so we do want to, it's not an in-place modification. We want to return the result. It's what we're seeing from before. And so now we want to apply add alternatives. Man, this is the real secret for why large language models are actually going to make people more effective in, data science ML. You spend so much of your time on things like silly pandas bugs or writing kind of like boilerplatey stuff that even though language models aren't that good at coding, they can still speed you up. Probably should have just opened ChatGPT and asked it to write this from the beginning. All right, we got it. We've got the answers there. So let's now do our more expensive thing and say our generated data is subset.apply add alternatives axis equals 1. All right, that's gonna take a while because we've got pandas is designed to parallelize stuff locally. If you're doing if you're doing array type operations, you can get vectorized stuff out of pandas, but it's not designed to be able to do things like that thread pool executor. So this is going to take some time to run, but I'll just go ahead and run it. And then, inshallah, this will finish with in like a minute or two. And we'll be able to look at the results. But I think we're getting close to the end. Oh, we're a little bit over when I intended to end. So I'll stick around for a minute or two and see if it finishes quickly. But yeah, so thanks for tuning in, to everybody who tuned in to watch this little walkthrough of this tutorial and then live coding session on on doing a little bit of data generation. Yeah, so the overall takeaway from this is that you definitely, when you're approaching solving a new problem with ML, you want to spend some time on exploratory data analysis. And so that will, lead to a ton of dividends if you actually spend time like looking at your data. So other people definitely have said this. I'm not the only one to say this. Jeremy's not the only one to say this, but I think it's just very tempting not to look at your data, and to ignore that in favor of infrastructure and like software engineering and ops, to ignore it in favor of like fun modeling problems in math. But I think those things are all lower return on investment than spending time with data. So, then the other important piece here is that large language models aren't just for solving ML problems in the like narrow way that people think of them, where ML is, is used to produce an entire product, or you create an entire technology that's this, question answering system or image recognition or whatever. It's also something that you can just use to accelerate all kinds of things that you are doing. So at the end, we were doing data generation using a language model. You can also explore your data using a language model. So doing exploratory data analysis of natural language data with a language model is a great way to speed up that phase and more quickly get the value out of that analysis phase. So those are I think the like key general takeaways. If anybody else has any thoughts as we're closing out here, don't be shy about putting them in the chat. All right, so hopefully that generated data task worked, because it's done. Let's sample an example. All right, A0, A1, A2, A3. All right, looks like some of them generated wrong amounts of answers. Not necessarily all 4, sometimes as many as 6. So that's a bummer. What happens when we drop NA? We might have nothing when we drop NA. Let's see what happens. Oh, only one of them generated all 6. So yeah, that's so, that was a failure mode of the language model for generation that we didn't think about, which is if it writes answers that are multiple lines, then we're going to end up with these like extra fake answers. So we wouldn't learn too much from doing actually analyzing this data, but the quick thing to do would be to add check the lengths, see that the lengths look right. But I think all we're going to see is that there's some messy stuff in there from the nans, from the like shorter, from the answers being, formatted incorrectly. So yeah, generating data is tough. You can't do it in, I guess, 20 minutes live, but I would be confident that in another half hour, without having to live explain what I'm doing, could definitely put together some okay data generation for this stuff. Hopefully seeing that was helpful. So question from Lunar Baboon, will you share your draft of the Kaggle notebook? Yeah, I can definitely share it. Anyone at Kaggle can find and view under the Apache license. Yeah. I should save a version before making it public, they say. No, not like that. Oh, save version up here in the top right. Let's call this, live stream 8/11, 2023, 08-11. Let's call that a save. I'm not going to save and commit because I was up to all kinds of wacky stuff, running things in different orders. Not great Jupyter hygiene, but, when you're running it live, you can't always be super careful. All right, so save. I think, let me toss a link to that Kaggle notebook in case you want to play around. It's like very close to the notebook that Jeremy put up, which is linked at the top. There's just a little bit of this extra pandas code there, but yeah. So that's my take on this particular tutorial on. I think I agree with the vision on exploratory data analysis, on using LLMs, establishing baselines, all really generally useful techniques for approaching ML. I think the same approach for using foundation like pre-trained models to establish baselines and to do exploratory data analysis also apply if you're in more of an not in the NLP world, but maybe more in an image world, using things like CLIP to explore data sets. I think it's pretty generally applicable. So hope you enjoyed it. We'll continue doing some of these little live streams, going through walkthroughs, sharing my thoughts on them, writing a little bit of code live here on the Full Stack Deep Learning channel. So if you want to get notified about that, follow us on Twitter, subscribe here on YouTube, and hope to see you around there in our Full Stack Deep Learning Discord, or out there in the wild world of building applications with ML and language models. Thanks everybody for coming. Thanks especially to the folks who asked questions and said hello in the chat. It's nice to know that there are other people on the other end of this digital connection. So much appreciated to all of y'all, and take care. Peace.